Okay, pre-cal, here is our quest review video. So we are verifying, and once again, I'm letting you know I'm going to give you the tangent formulas: tangent of a sum, tangent of a double angle, tangent of a half angle. So you're going to have those, but you have to know all the sine and cosine formulas. So if we're going to verify here, then obviously we're not doing anything to this right-hand side because it's very, very simple. So here we've got sine of the double angle over sine minus cosine of the double angle over cosine. So let's make a substitution for these two double angles here, and let's see if we can make something cancel. So the sine of the double angle is 2 sine x cosine x over the sine x. So we are going to be able to make that cancel. And then minus the cosine of the double angle. Now the cosine of the double angle has several options. So for that cosine double angle, you got to make a choice. And so let's go with the cosine double angle is 2 cosine squared minus 1 over cosine x. Let's see what happens when we give this a shot. So first of all, over here, all we've got left is 2 cosine x minus, now remember, we've talked about this, we've got the cosine x, that is a single term, so it is the common denominator for both of those terms. Just remember to be careful with that minus. It is going to get distributed there. So I think I'm even going to put this in parentheses to help out. So we've got 2 cosine squared x over cosine x minus 1 over cosine x. So here, that cancels, and we're left with 2 cosine x minus 2 cosine x. That's good. And then minus that negative plus 1 over cosine x. So 2 cosine x minus 2 cosine x, that cancels. We're left with 1 over cosine x, and of course 1 over cosine x is actually equal to secant x, and that is our right-hand side. So on that one, we didn't even touch the right-hand side. We completely transformed the left-hand side to be the right. Be on the lookout for opportunities to make substitutions with double angles, angle sums, angle differences. You have to know those for sine and cosine. Next, given cosine of 2 cosine inverse 1/3, evaluate for the exact value. So we worked on these today, and we're going to do this using substitution. So I will let z equal cosine inverse of 1/3. And everything's positive, so let's just assume everything's going to stay positive. So from here, if z equals cosine inverse 1/3, then the cosine of z equals 1/3, which of course directly translates to a triangle. So cosine is adjacent over hypotenuse. So 1 and 3, which is going to leave our missing side to be 2 root 2 by Pythagorean theorem. So next, remember, we're letting all of that be represented by z. So we end up with the cosine of 2z. So this is the cosine of a double angle. Once again, lots of options for cosine of the double angle. I'll use how about cosine squared z minus sine squared z this time. So now all we got to do is do a direct substitution and then follow order of operations. So the cosine of z is 1/3, and the sine of z is 2 root 2 over 3. So both of these are being squared, so when we follow order of operations here, we end up with 1/9 minus 2 root 2 squared is 8 over 9. So 1/9 minus 8/9 is negative 7/9. And that is our simplified answer. Is it correct to be negative? Yes, because think about it. We do know that z is an acute angle, but if we were to double z, if we double any of the angles in the first quadrant, it's going to land us in the second quadrant, and in the second quadrant, cosine should be negative. Therefore, our answer should indeed be negative. So that is the second one. Okay, so this has got a lot going on, and sorry, I had to use the magic tape there. So find the exact value of the expressions given that tangent x is 2/3 and cosecant y is 2. So we need to find x and y given that they're both in quadrant 1. So let's go ahead and let's use our given information to draw two diagrams here. So first of all, for x. So there's our x. Tangent of x is 2/3, opposite over adjacent. So find that hypotenuse. So 2 squared plus 3 squared equals c squared. That's 4 plus 9, that's 13. Our hypotenuse is root 13. Let's also go after the y. So once again, it's all in quadrant 1. Now if cosecant y is 2, that must mean that sine of y is 1/2. So there's y, there's 1, there's 2. This actually is a 30, 60, 90 triangle. So there's our two diagrams, and now we're going to go after the cosine of the difference. Cosine of the difference is coming up first. So let's do cosine difference first. So cosine of x minus y, cosine of a difference, and I am just going to slide this up so you can be certain to see everything. So cosine of a difference, cosine x, cosine y, plus sine x, sine y. And from here, we go straight into using the substitution property. Once again, you have to know the cosine of the sum, cosine of the difference. So cosine x is 3 over root 13. Cosine y, root 3 over 2. Sine of x, the sine of x, 2 over root 13. And the sine of y is 1/2. So we end up with everything over 2 root 13. Now I know those 2's will cancel, but don't. Think about what we're trying to achieve here. So we're trying to add these two expressions together, so just let it ride. And we end up with 3 root 3 plus 2. Now, if you leave this as an answer, I'm going to take off 2 points because you need to rationalize the denominator here. So we're going to multiply by root 13 over root 13, and we are going to get 3 root 3 times the root 13. That's 3 root 39 plus 2 root 13 all over 2 root 13 times root 13. That will be 2 times 13, which will be 26. This is your cosine of the difference. Cosine of the difference. Remember, the cosine of a difference is a sum. Next, let's do the tangent of the double angle. The tangent of the double angle. And I'm going to check my tangent of the double angle because I've already told you I'm going to give it to you, because I'll be honest, I don't know the tangent formulas off the top of my head because I always just use the sum and the cosine, the sine and the cosine. So the tangent of the double angle, the formula is 2 tan y over 1 minus tan squared y. So that's the formula. So we need to go to the y triangle. There she is. And that's going to be 2 times the tangent of y. The tangent of y, opposite over adjacent, 1 over root 3. over 1 minus 1 over root 3 squared. So we end up with, following order of operations, 2 over root 3 over 1 minus 1/3. 1 minus 1/3 is 2/3. So finishing this off, we have 2 over the square root of 3 over 2/3. So division by a fraction turns into multiplication by the reciprocal. So we have 2 over root 3 times 3 over 2. 2's cancel, so we get 3 over root 3, which will now rationalize, and times root 3 times root 3. We end up with 3 root 3 over 3, which of course, bam, root 3, the end. Which makes sense because this is a 30-degree angle, and the tangent of 2 times 30, which is 60, is root 3. So guess what? That formula works. Next, we've got C, which is the sine of the half angle. The sine of the half angle. Remember the half angles, those are the formulas underneath the radical. So think about what we've got. We're in quadrant 1, so half of y, already knowing that y is equal to 15, our answer will be positive. And the sine of the half angle is 1 minus cosine y all over 2. So that's your formula. You have to know that. So equals, and we know it's staying positive, so I'm just going to let that be, 1 minus the cosine of y. The cosine of y is root 3 over 2 all over 2. And we worked several problems in class like this. First thing I want to get rid of is this 2. Whatever the denominator of that fraction is, that's what I want to get rid of. And it works out really nicely here because when I multiply by 2 over 2, I end up with the square root of 2 minus root 3 all over root 2 times root 2, which is 2. And that is the simplified form of the sine of the half angle. So those are 3 problems that I've made for you. Our quest tomorrow has 8 total questions on it. You will not be using a calculator. You definitely have to know all of the identities when it comes to Pythagorean identities, sum and difference formulas, double angles, power reducing, half angle. Have to know all of those. I will see you all tomorrow in class.